Hello, everybody. My name is Heikki Kokkinen from Fair Spectrum. Fair Spectrum is a company from Finland. We provide dynamic spectrum access services, software, and consulting. Fair Spectrum was the first company to open a TV whitespace commercial service in the UK. We are the only company who has licensed access deployment level listing on CPT website, and we have just received conditional approval from FCC to become CBRS SaaS administrator in the US. The LSA pilot system which we implemented, on the orange boxes we have marked the areas in the system that were implemented by Fair Spectrum. The system worked as was heard earlier, that when before the broadcaster begins to use PMSC, they open LSA Warner, and LSA Warner senses the available mobile network operators, networks, and the base stations, and then provides the information to LSA system, and then LSA system controls mobile network operator network such that the interfering base stations either are shut down or their power level is decreased. For pilot purposes, this was implemented such that we had two separate servers in Amazon Cloud, one for the LSA Warner, which made the request to the other server, and then we had a Java application inside the mobile network operator, which made requests through the MNO firewall to the other server in the LSA system, and this way the information could be provided from the LSA Warner through LSA system to mobile network operators network. In practice, probably there would be tunnels through the system so that these servers would not be necessary needed this the same way as in the pilot it was implemented. The important thing to note here is that according to my understanding, this is the first dynamic spectrum access system where sensing was used to sense the secondary user. So all the other systems, either they sense the primary user or they use administrative information provided by the regulator or directly incumbents to the spectrum management system. And then this sensing the primary user could be divided into two different categories. One is that very fixed sensing stations are sensing the network, like here the CBRS environmental sensing capability sensors. They are fixed sensors at the coastline, and then the other option is like the DFS in Wi-Fi 5 GHz systems where the sensing is at the secondary user, and it tries to locate the meteorological radio use. The benefits of this system compared to administrational data, so all regulated, all dynamic spectrum access systems which have regulation are based on administrative information, and then there's a slight kind of use. So in CBRS ESC and in FCC TV whitespace, there's an option for sensing as well, but the primary way of protecting incumbents is using administrative data, and administrative data has to be collected, has to be checked and maintained, and then after that it can be provided to protect the incumbents. And this kind of method, it fits to certain purposes, especially when there are not so many changes by location, and the timing is not so critical, so it doesn't have to take place in seconds. But then when we are talking about kind of critical communication, some of the PMSC, for example, is used for, and these wireless camera links can be used for critical communication, then the fast response that this LSA Warner type of protection provides is superior. The other benefit is that the propagation models are depending on what data is used to apply those propagation models. So there might be clutter data, there might be topographic data, there might be building height databases used, but always there are some surprises. There can be temporary buildings, there can be big trucks, all kind of things which are between these communication links, and none of the administrative information-based interference protection systems are able to take into account these temporary man-made obstacles. But in this kind of sensing, where the sensing is taking place in the receiver of the primary user, very accurate information, so the most accurate information is available at the sensor. Then compared to the sensing, so if we are sensing at a location which is so like in CBRS ESC, where the sensor is located in a fixed location, it's not directly at the primary user location, it's not directly at the secondary user, then its accuracy is not very high. So location accuracy is not very high. And then in the case that we are sensing the primary user, then we are sensing the transmission of the primary user, and it might be that the transmitter and the receiver, like in these PMSC setups, they can be located in different places, and at that way the accuracy of the sensing the secondary user is much higher than the sensing systems sensing the primary user. Another issue is that if we have continuous use of spectrum by the secondary user, and then at the period of time you have to make then sensing, sense the primary user, there might be transmissions around the secondary transmissions which are interfering the sensing of the primary user, and this does not this is not a problem in the case of sensing the secondary user, as all secondary user can be basically detected. Also, from the timing perspective, if we are so again comparing sensing the primary user versus sensing the secondary user, when we sense the primary user, the primary use has to be begun, or has to have been begun already at that time. So there's always some overlap of the time that when this new when the LSA system has affected the secondary user's network. But in the case that we can do the sensing before we begin the primary use, then the protection is already in place before the primary use of spectrum begins. As a summary, this sensing of secondary user, it's a unique capability demonstrated and piloted in this LSA Portugal pilot. And compared to sensing the primary network and using the administrative information for dynamic spectrum access, it provides fast responses. It can, so man-made obstacles, it can take always into account all even temporary man-made obstacles. The sensing location is always correct compared to the other sensing locations, and the secondary use does not interfere the sensing performance of the sensor. And then the time perspective, so by this method, the protection is always in place before the transmission of the primary user, and it can protect throughout the primary usage. So thank you very much, and I'm happy to take any questions or comments when the time for that in the panel begins. Thank you.